This experiment is relatively easy, so just sit in your mind. Its objective, there are four. One is to learn the sample preparation. Second is to learn to use the optical microscope. The third one is to learn to identify different types of microstructure. The last one is to use the image analysis software to obtain the quantitative information which you got. There are three parts of the experiment: the theory briefing, the experiment, and the report. So first is introduction. From the material side, we can divide the materials use different types. For the solid materials, there are three types: the metals, ceramic, and the polymer. The metals consist of the pure elements, which has the high thermal and electrical conductivity. The ceramics always are oxides, carbides, or nitrides. The polymer consists of the small organic molecules. So from the engineering aspect, the materials also divided into three types: the composites, semiconductors, and the biomaterials. Composites are the two or three metals, ceramics, or polymers connected together. The semiconductors, due to its special electrical properties, and the biomaterials are related to the human beings. So from the material structure, there are four levels. The first level is the subatom structure. In this level, we investigate the materials like by the electrons, atoms, electrons, phonons, something like this. The second level is atomic structure. We investigate the materials by the atoms or molecules. The third part is the microscopic structure, which we investigate today. The last one is the macroscopic structure. We can see it. So in order to see the microstructure, we need the object is the metallography. Metallography is the method for you to prepare the material surface smooth and clean to see their microstructure. So there are three major steps. One is the sample mounting, the second is grinding and polishing, the third one is chemical etching. The sample mounting is because we do not need a large piece of material to see, just need to a small amount of materials mounting to the polymers. The grinding and polishing to make the material surface clean and smooth. The chemical etching is to review the microstructure more clear. In order to see the microstructure, so we should use the optical microscope. This is a typical optical microscopy. This is our eyepiece here. This is the objective lens. Here we put our sample. We use the focusing knob to focus our surface. So for optical microscope, there are two important things. One is the magnification of the microscope, and the second one is the resolution. So first is the magnification. Always in an optical microscope, there are two values. One is labeled here, and one is labeled in objective lens. So the total magnification is this value multiplied by this value. For example, here it shows 10 times, and objective lens shows 10 times. So the total magnification is 100. And the second is the resolution. Resolution is equal to the speed of light multiplied by the wavelength of light divided by the NA. So our value is small, it means the resolution is high. So in order to get a small value, there are two methods. One is to increase the NA or decrease the wavelength of light, because C is a constant. That's the reason why the electron microscope has a high resolution than the optical microscope, is due to the wavelength of light is much larger than the wavelength of electrons. So what means a large NA? That means more. That means the aperture is large, can let more light come into the aperture. So for the optical image, we use the light waves. So the four important information in the light wave is the amplitude, wavelength, phase, and polarization. This will not discuss today. So the amplitude gives us the brightness. That means if we can see the image in the microscope should have a good brightness. Otherwise, you cannot see anything. The wavelength gives the resolution we discussed before, and the phase always transforms into the contrast. If the contrast is less than 20%, we cannot distinguish the image. This is the common microstructure of metals. It's a single phase. This image shows the typical microstructure. This polyhydro shows is the green, and between the green is the green boundary. This structure called green structure is a typical structure of the microstructure. So from this image, we can get two kinds of quantitative information. One is the grain size distribution, and another is the number of the sites per grain. The more complex system is the two-phase system. This is the eutectic alloy system. In the left hand, here is the copper, 100%, and here is the copper 3 phosphor. It's another compound. So from in the C point, here is the eutectic phase. Always eutectic phase shows the black-white laminar structure in the microscope. And the dark one is the copper, and the light one is the copper 3 phosphor. So image C shows the hyper-eutectic 10.5% phosphor here. Means we decrease the temperature to here, then we can get the copper 3 phosphor. Until to this line, we can get the eutectic phase. But in the image C, we can say the light one is the first to come out, the copper 3 phosphor, but the background is black. That's because the magnification is low. If we enlarge some area of here, we can see the D image. There are also a laminar phase in the background. It's the dark light laminar image. It's the eutectic phase. When we deal with our materials, there are always the deformation when process the materials. Figure A shows the zinc, the slip line deformation, and the image B shows the deformation cannot clearly see the green structure. Always we can recrystallization of the image B. We can also get again see the green structure. In this experiment, the software is the image J. You can download from this website. It's the free, and the format of the image should be the TIFF. So the total process is just adjust the brightness, contrast, or gamma control to yield an image for the quantitative analysis. So this is the experiment today. We have prepared the sample. You do not need to do the grinding, polishing, etching process. Just focus the image, take a picture, and use the software for quantitative analysis. Due to the time limited in this experiment today, so the material just two should be used. One is the control copper, it's the pure copper. It shows the single phase, it shows the green structure. And another is the LABII alloy. It's the T weight percentage is 80 weight percentage. It shows the two phase. One is the protective phase, and one is the eutectic phase. This is the LABII phase diagram. Also, we use the 80% of tin. So we decrease the temperature here. Firstly, we can see the beta phase is the light one. And then we come to the eutectic phase. We may see the dark light laminar phase. So for you today is the formal report right. So the formal report should contain at least these 7 parts: objective, theory, experiment, result, discussion, conclusion, and reference. Remember, there will be a deduction of the marks for the report submission. Okay. Next, Benson will give you the demo of the experiment.
Benson, guiding me today's experiment. Before I go on, please look through. Sometime during your third year, you will get hands-on on some of the further elaborate process. So this one is the anti-stick powder. Okay, so it won't stick to the ram when you finish your mount. This one is your sample, okay, the material, which you have already cut into smaller pieces. Lower down the ram is to make space for your ratings. Okay, so you call the ratings, and so that you can expand. When you are taking the ratings, right, try not to be greedy. Okay, just take one full scoop per you. Take one level scoop. Here you realize that they say that you have to turn back 3/4. Okay, so this is to make space for the ratings. Okay, so it won't actually pour out or expand. Press the wrap up, then the sample mount is directly below the closure. So this one is your final product. And the other one is your grinding and polishing.
Saya Facebook lah.
Okay, so you will choose your correct paper, except paper, then based on your grinder.
Then I follow you now.
You have to turn on your running water. Okay, so this is to wash away all those contaminants. Okay, so when everything clog up then. Yeah, so you grind in the middle of it, then it's supposed to be much smoother. Okay. So here's the polishing part. Same, you have to place a polishing cloth. Ensure that it's flat. And use some diamond paste, okay, a little bit will do.
Diamond paste. Still the piece around.
Same thing,
That's all I was thinking also. Huh? That's what I was thinking also. Good money. Oh.
So this will give you a very glossy. So that's the two videos.
What do you mean?
So
If I search
I'll
exactly
go
this video,
into the demo now. Maybe